are the parts. Plant- Plants are having roots also. So since in plants roots are there, stems are there, fruits are there. In plants, branches are there. In plants, seeds are there. So in like that, in animals, hands are there, legs are there, heads are there. So all these are different parts of the living being. So in human
Right.
beings, you are having kidney, you are having liver, you are having heart. All these are organs. So so
Yeah.
the so the study of living things, or you can say chemical study of living things. That is organic
Mhm.
chemistry. In chemistry, organic chemistry, organic chemistry, or you can say, is a branch of chemistry in which we study about the living things, living compounds, organic compounds. Fine.
Right.
What we study in organic chemistry? In organic chemistry, we study about organic compounds. What are the organic compounds? Compounds which are present inside the organisms.
Yeah.
Compounds which are present in the living beings are called organic compounds. This was
Hmm.
the very basic, very first, very initial definition of the organic chemistry, or you can say organic compounds. What I have told you, in organic chemistry, you study about organic chemistry. Now they asked what organic compounds are. Organic compounds are those compounds which are present inside the living beings. So those compounds are
Right.
called organic compounds. Now there was a question, why organic compounds are present inside the living beings only. So Berzelius gave here a theory, that is Berzelius vital force theory. That is
Hmm.
Berzelius vital force theory. Berzelius vital force theory. According to that
Yeah.
theory, inside the living being, there is a very special kind of force. Inside the living beings, there is a very special kind of force. That force is called vital force. That force is called vital force.
Vital
Since
force.
inside the living being, this vital force is there, and that vital force is responsible for making of organic compounds. This vital force is responsible for making of organic compounds inside the living beings. So that is
Right.
why only inside the living beings this compound can be formed. Outside the living being, this vital force can't be there. So outside the living beings, organic compounds can't be prepared. Now,
Right.
but the student of Berzelius, what was his name? Wohler. Wohler was a student of Berzelius. What he did, he synthesized urea inside the lab.
Right.
What he did, he synthesized urea. Where? He synthesized urea there outside the living beings. So he proved Berzelius wrong now.
صلاة
Berzelius
العشاء.
was saying that only inside the living beings organic compound can be synthesized. But Wohler
Right.
synthesized organic compounds outside the living beings. In this way, he proved Berzelius wrong. Fine.
Okay.
In this way, he
Yeah.
proved Berzelius wrong. So from where he synthesized this urea in lab,
Yeah.
what urea is?
Uh.
NH2CO NH2. What this is? This is urea.
Hmm.
NH2CO NH2. This is carbamide. What this is? This is
Carbamide.
carbamide. This
Hmm.
is urea.
Yeah.
He synthesized
Wait.
urea,
Let me see.
that is carbamide, in the lab. In the lab, he
The lab.
synthesized this NH2CO NH2, that is urea. Or how else we can write it? We can write it NH2 whole twice CO. So in this way, he proved Berzelius wrong. Now,
Right.
so this definition was proved wrong. So now what they said, the second definition related to this organic compound, they said was compounds of carbon with hydrogen, oxygen, nitrogen, phosphorus, sulfur, fluorine, chlorine, bromine, and iodine.
Mm-hmm.
Compounds of carbon, compounds of carbon, compounds of carbon with hydrogen, oxygen, nitrogen, phosphorus, sulfur, and fluorine, chlorine, bromine, iodine. These compounds are called, these compounds of carbon with these elements are called organic compounds. What they said, that if carbon combines with hydrogen, oxygen, nitrogen, phosphorus, sulfur, fluorine, chlorine, bromine, iodine, then such compounds are called organic compounds. From this definition, if we see carbon and oxygen combine together to form carbon monoxide and carbon dioxide. From this definition, see carbon combines with oxygen to form carbon monoxide and carbon dioxide. So these compounds should also be organic in nature, because according to this definition, compounds of carbon with any of these elements, that will always be organic in nature. Here,
Hmm.
carbon is combining with oxygen to form CO, carbon monoxide, and CO2, carbon dioxide. So it should
Dioxide.
be organic. It should be organic,
Yeah.
but was not organic. But was not organic.
Organic.
Carbon monoxide and carbon dioxides are not organic compounds. So this definition
Then wait, what's a
also,
carbonic oxide?
pardon beta,
What would be a carbonic ox a carbon
Ca- carbon
compound?
mono, this is carbon monoxide and this one is carbon dioxide.
Yeah,
Since the
but they combine with carbon, right? So
they are made of carbon and oxygen, then too are not organic. What's the reason? That we will come to know there in the third definition.
okay.
What the reason why you are not ready to call them, you are not ready to classify them, you are not ready to tell that these compounds are organic? What's the reason? That we'll discuss there in the third point. There we will come to know about that point. Is this okay,
Okay.
beta? Fine.
Yeah.
See the third definition. Third definition. So here this definition also proved wrong. You said that compounds of carbon with oxygen should be organic but are not organic. So here this definition
Mm-hmm.
proved wrong. Na?
Yeah.
So there was need of the third definition, the accurate definition. So what they said, hydrocarbons, hydrocarbons and their derivatives. Hydrocarbons and their derivatives
Derivatives.
are organic compounds, and their derivatives are organic compounds. How it is, that we will see there in a reaction, are called organic compounds. Hydrocarbon and their derivatives are called organic compounds. What's the meaning of hydrocarbon? Hydrocarbon means compounds of carbon with hydrogen.
And hydrogen,
Compounds of carbon
right?
with hydrogen. That is called hydrocarbon. Now see what this is.
Okay.
This is methane. What this is? Methane.
Methane.
So it is hydrocarbon, because it is made of
Okay, yeah.
carbon and hydrogen only.
Yeah.
Since it is made of carbon and hydrogen only, that's why it is organic compound. That's why it is hydrocarbon. Is this okay, beta?
Yeah. It
Now
is.
see. Now see. CH4 combines with chlorine. One hydrogen combines with one Cl. One hydrogen combines with one Cl to form HCl, and what you will get? You will get
Right.
CH3Cl. This CH3Cl further reacts with one more Cl. This Cl, CH3Cl, CH3Cl further reacts with one more Cl. So this one Cl combines with one H to form HCl, and what you will get? CH2Cl2.
Hmm.
This hydrogen will be replaced, and instead of that hydrogen Cl will be added. So what you will get? CH2Cl2. This CH2Cl2 further reacts with one more Cl2, and then again one H will combine with this one Cl to form HCl, and what we will get? CHCl3. This CHCl3 further, this CHCl3 further reacts with one more chlorine. This one H
Mm-hmm.
further reacts with one H, and in this way that last hydrogen will also be removed from CHCl3 and we will get CCl4. One by one, one by one, one by one, all the four hydrogen atoms are removed and instead of hydrogen atoms Cl are placed. So this is hydrocarbon and this one is derivative. This is also derivative. This is also derivative and this is also derivative of hydrocarbon. That hydrocarbon is methane. That hydrocarbon is methane.
Okay.
So this
Okay.
was methane. From this methane you have derived, you have made methyl chloride. What this was? Methyl,
Mm.
methyl chloride.
Yeah.
Fine. What this was? Methylidene chloride. What this was? Methylidene,
Methylene chloride.
methylidene chloride. Chloride.
Mm-hmm.
And what about this one? This was chloroform. Was this what this one? Chloroform.
From.
CHOLORO. Chloroform. And what about this one? This was carbon tetrachloride. What this one was? Carbon
Carbon tetrachloride.
tetra, carbon
Chloride.
tetrachloride. Is this all okay, beta? Once again,
Yeah.
I'll repeat the name of all these compounds. What this is? This is methane. What CH4 is? Methane.
Methylene.
What
Yeah.
CH4 is? Marsh gas.
Methane. Huh?
Marsh gas.
All right.
Since this methane is there in marshy places na, swampy areas na,
Huh.
marshy
Yeah.
places, swampy areas. So that is why it is known as marsh gas.
Okay.
It is also known as fire damp because it is there in dampy places na, marshy places na, swampy areas na. So it is known as
Hmm.
fire damp.
Fire. Okay.
This is the simplest hydrocarbon. This is the simplest hydrocarbon, simplest alkane.
Hmm.
From this methane, one H will combine with this one Cl to form HCl, and in place of that H, one Cl will be added. So instead of CH4, you will get CH3, and in place of one HCl will be added. What you will get? You will get CH3Cl. What is the name of this CH3Cl? Methyl
Methyl
chloride.
chloride.
Fine. Now see, it will
Yeah.
react with one more Cl2. This one Cl combines with this one H to form one HCl, and in place of this one H, this will remain. This will be remaining only CH2, and instead of this H, one more Cl will be added. So instead of Cl, it will become Cl2. So CH2Cl2. Two hydrogens are removed from CH4, and in place of two hydrogens, two Cl will be added. This is called
Okay.
CH2Cl2. This is called methylidene chloride. Methylidene. Methylidene chloride. What? Methylidene chloride or methylene dichloride. Then this CH2Cl2 will react with one more Cl2. One H will be replaced from here, and that one H will combine with this one Cl to form one HCl, and in place of that H, one Cl will be added here. So this will become CHCl3. What it is? Chloroform. What it is? Chloroform. This is trichloromethane. This is trichloromethane. This is chloromethane. This methyl chloride is chloromethane. This methylidene chloride is dichloromethane. And this
Hmm.
CHCl3 is known as
Chloroform.
trichloromethane. This trichloromethane CHCl3 chloroform further reacts with one more Cl2. Further reacts with one more Cl2. Again one Cl will combine with this one H to form HCl, and in place of that H, one Cl will be added. So this will get converted into CCl4. This will get converted into CCl4. What this CCl4 is? CCl4 is carbon tetrachloride. What this CCl4 is? Carbon
Carbon tetrachloride.
tetrachloride. Its another name is pyrene. Its another name is pyrene, Pyrene. Why it is known as pyrene? Because it is used as a fire extinguisher. Because it is used as a fire
Fire
extinguisher.
extinguisher.
Since it is used as a fire extinguisher, that is why it is known as pyrene. It is also known as tetrachloromethane. It is
Hmm.
also known as tetrachloromethane.
Tetrachloromethane.
Fine. It
Yeah.
is also known as perchloromethane. What is its another name? Perchloromethane.
Perchloromethane. Okay.
See, in CH4, how many hydrogen atoms are there?
4.
And you have removed all the 4 hydrogen atoms.
Right.
And instead of hydrogen, what you have written?
Cl.
Cl. So when all hydrogen atoms are removed from an alkane, and instead of hydrogen atom, halogen is added, such compounds
Hmm.
are called perhalo compounds.
Okay.
If all the 4 hydrogen atoms are replaced by chlorine, Cl, then
Hmm.
such perhalo compounds are called perchloromethane. You have removed all hydrogen atoms and instead of hydrogen atom you have added Cl now. So it will be
Yeah.
perchloromethane. This CCl4 is also known as perchloromethane.
All done. Okay.
So what all the names of CCl4 are? Tetrachloromethane,
Um,
fine.
there's methyl
Tetrachloromethane,
chloride.
carbon tetrachloride, tetrachloromethane,
There's chloroform.
tetrachloromethane, carbon tetrachloride, pyrene, perchloromethane. Perchloromethane.
Yeah. Methane.
All these are the names of
Okay.
CCl4.
Got it.
Okay, fine. Now see, what was parent? CH was parent. And from that
Hmm.
CH4, you obtained CHCl3. Sorry. You obtained CH3Cl first, then you obtained
Yeah.
CH2Cl2, then you obtained
H2Cl2.
CHCl3, then finally
Mm,
you got CCl4.
Cl.
So see,
C.
one by
Yeah.
one, hydrogen is reducing now. Here it is 4, here it is 3, then 2, then 1, and then 0.
Yeah.
So this was hydrocarbon, and these all four are its derivatives. These all four are its derivatives. These all four are its
Yeah.
derivatives. So these all are hydrocarbons. This is what the definition of organic compound was. Hydrocarbon and their derivatives are called organic compounds. Hydrocarbon and their derivatives are called organic compounds. So this was hydrocarbon and these all were its derivatives. So these all are 1, 2, 3, 4, 5 are organic compounds. Are organic compounds.
Okay.
Fine. This is the
Yeah.
most modern definition. This is the most modern, most correct definition of organic compounds.
Okay. I got it.
Now, in second definition, you said CO and CO2 are not organic compounds. You said that CO and CO2 are not organic compounds now. What you said?
Yeah.
CO and CO2 are not organic
Not.
compounds. Why? Because CO and CO2 are not derivatives of hydrocarbon.
Okay.
CO
Okay.
and CO2, since can't be derived from hydrocarbons, that's why are not organic compounds.
Okay. Okay. I got it.
Is this clear, beta?
Yeah. It's clear.
Now, So this is the first thing you should know, what the definition of organic compound is. So what you said first, organic compounds are the compounds which are present inside the living beings. Why they are
The
only present
Bergelius
inside the
vital
living?
force theory.
Yeah, why they are only present inside the living beings? Because inside the living being there is a very special kind of force that is called vital force, and that vital force is responsible for making of those compounds. Since outside the
Right.
living beings this force is not there, so that is why these compounds can't be present there, they are outside the living beings.
Hmm.
This was given by Berzelius. But Wohler,
Hmm.
what he did, he synthesized these
He.
organic compounds outside the living beings. They are there in the lab. In this way, he proved his own teacher Berzelius wrong by synthesizing organic compounds inside the urea, inside the lab. Sorry, what that compound was? Urea. What that compound was?
Yeah.
How
Urea.
he synthesized it? I'll explain you that too. What he did, he took
Hmm.
NH4CNO. What NH4CNO is? Ammonium cyanate. What this NH4CNO is? Ammonium
Ammonia
cyanate.
cyanide.
What this NH4CNO is? Ammonium cyanate. What he did, he heated this ammonium cyanate. Ammonium
Cyanide.
cyanate
Yeah.
in lab, and this ammonium cyanate was inorganic compound. He heated this inorganic compound there in the lab, and what ultimately he got? He got NH2CO, NH2. See how many nitrogens here? Two nitrogens now, one and two nitrogen.
Yeah.
How many hydrogens are there? Four. Here two plus two,
Four.
four. What rest is? One carbon, one oxygen, one carbon and one oxygen.
Okay.
So such reactions are called isomerization reactions. Such reactions are called isomerization
Isomerization
reactions, in which
reaction.
there is no addition, there is no subtraction, there is no addition, there is no dissociation, decomposition, breaking, just the arrangement of atoms are getting changed. So such reactions are called isomerization reaction. What this urea is, what this carbamide is, that's organic compound. What it is? It was the first organic compound synthesized there in the lab.
Okay.
This was the first organic compound synthesized there in the lab.
Hmm. Okay. Done.
See, here inorganic compound is converted into organic compound now.
Mm-hmm.
There is no addition or there is no combination of two or more elements, or there is no breaking of any compound. Here it is one compound, there also it is one compound, just only arrangement of atoms are getting changed. So such reactions are called isomerization reactions.
Yeah.
In this isomerization reaction, inorganic compound ammonium cyanate is heated there in the lab and will get converted into urea, NH2CO, NH2, that is carbamide, that is organic compound. This was the first organic compound which was synthesized there in the lab.
Yeah.
This was the first organic compound which was synthesized in lab.
Organic compound synthesize in lab. Okay.
The second organic compound The second organic compound synthesized in lab was acetic acid, CH3COOH. What it was? Acetic acid. What it was? Vinegar.
Acetic acid.
Vinegar. What was its? These are its common name. What was its IUPAC name? Ethanoic acid. This was the Second organic compound which was synthesized in lab. This was the second organic compound synthesized in lab. What it was? It was acetic acid,
Okay.
vinegar. It's food preservative. What it is? It is
Food
food
preservative.
preservative. If you'll add this there in food now, then we can preserve food for a long time. In restaurants, food they are keeping for 1 week, 10 days now.
Mm-hmm.
In restaurants, they are keeping food for a long time now. So how they
Yeah.
can do that? Just by adding this preservative, food preservative, then only they can keep it for a long time.
Okay. Um. H-O-O. Okay.
First organic compound synthesized in lab was urea. Second organic compound synthesized in lab was acetic acid,
Vinegar.
vinegar, or ethanoic acid. Third organic compound synthesized there in the lab. Third organic compound synthesized in the lab was CH4, methane. This was the third organic compound synthesized in lab.
CH4 methane. Okay.
Fine, beta?
Yeah. Fine.
So this was hydrocarbon and these all are derivatives of hydrocarbon. So all the five compounds are organic compounds. This is the most modern
Hmm.
definition of organic compounds, that hydrocarbons and their derivatives are called organic compounds.
Yeah.
Fine. Now see,
Hmm.
now see
Yeah.
hydrocarbon. Hydrocarbon.
Hmm.
Just to study this hydrocarbon, what you should know first, valency of some elements you should know that will be used there in the organic chemistry. Only we will be talking about the valency of those elements which will be there in the organic chemistry, in organic compounds. Valency of carbon is 4. Valency of hydrogen will be 1. Valency of oxygen will be valency of oxygen will be 2. Valency of nitrogen and phosphorus will be 3 and 5. Valency of oxygen and sulfur will be 2, and valency of chlorine, bromine, and iodine will be 1. Valency of these 10 elements you should remember. Valency of carbon will always be 4, hydrogen will always be 1, oxygen and sulfur will always be 2, nitrogen and phosphorus will always be 3 and 5, and fluorine, chlorine, bromine, iodine will always be having valency 1. Will always be having valency 1.
Nitrogen and which one, sir?
Nitrogen and phosphorus 3 and
Okay.
5. 3 and 5.
Wait, why is it separate?
Beta,
Why is it 3 and 5?
3 and 5. It can be 3, it can be 5, both. They can show two valencies. It can be 3, it can be 5.
Okay. And for fluorine, chlorine, bromide, and what's the
Bromine and
valency?
iodine, it is 1. It is 1,
One. Like hydrogen.
like hydrogen.
Okay.
Should I go to the next
Done.
one?
Yes.
After 5 7 minutes, na beta, This will be
Hmm.
stopped. Meeting will be stopped. So rejoin it immediately. I'll
Okay.
reconnect it.
Yeah,
Fine. After 8 minutes around, it will be disconnected, discontinued. So rejoin it again.
I will do that.
Fine. Every day it will be like this. Whenever we will be having class now, it will be like this. So just reconnect it.
Yeah.
Fine. Now see what you read. You wrote CH4. You wrote CH4. See how many bonds this carbon is having. 1, 2, 3, 4. So the valency of carbon here is 4.
Yeah.
What about this hydrogen? How many bonds this hydrogen is forming? 1.
One.
What about this hydrogen? It is also 1. This hydrogen is also 1. This hydrogen is also 1. 1. So the valency of carbon is 4 and the valency of hydrogen is 1. Valency means number of bonds.
Oh, okay.
Valency means number of bonds.
Okay. Give me a second. Just making the
Yeah,
diagram.
fine. You can please.
Okay, done.
See what I told you, what valency is? Number of bonds.
Yes.
How many bonds an element can form, that will be the valency of that element.
Yeah.
What else you can say? Valency is the combining capacity of an element. See the combining capacity of this carbon, what it is? 1, 2, 3 and 4. So the valency of carbon is 4.
Okay, that makes more sense now. Yeah.
Yeah, valency is combining capacity of an element.
Right. Okay.
Valency,
Oh, okay. Like H2O. H
yeah.
needs
See, yeah, you
two
have said
oxygen bonds.
H2O. You have said it is not organic compound. Since we are doing organic chemistry, but here I want to explain you valency and you said H2O, na, that's why I am explaining it here. But this H2O is not an organic compound. So this is not the right place to discuss about this H2O. But since we want to understand this valency properly, na, that's why I am giving you this example. See
Okay.
how many bonds this hydrogen is forming? 1. So the valency of hydrogen is 1. How many bonds this hydrogen is forming
Yeah.
with oxygen? 1.
One.
So the valency of hydrogen is 1. What about the oxygen?
Mm.
This oxygen is forming this one bond
Two.
and this one bond with hydrogen, two different hydrogen. So the valency of oxygen is 2.
Okay. Okay. I got it.
Now see, we'll see some more example. These two are over.
Mm-hmm.
These
Yeah.
two are over. Now, what have you said? You have said urea, NH2CO, NH2. Now, see this urea,
Hmm.
NH2, then C, double bond O, NH2. What the valency this nitrogen is having? 1, 2, 3. What about this nitrogen? 1, 2, 3. So the combining capacity of nitrogen, number of bonds this nitrogen is forming here is 3.
Okay. But why is there a double bond between oxygen and carbon?
Yeah,
Oh,
just
because
see.
oxygen needs
But
two bonds.
valency of oxygen is 2 now. So that's why you have written
Yeah.
a
Right.
double bond with carbon. What about carbon? See here carbon. What valency carbon is showing? 1, 2 and 2, 4 na.
Yeah.
1, 2, 3, 4. What the valency of carbon here is 4. What about the valency of
Okay.
hydrogen? Hydrogen everywhere is 1. Hydrogen everywhere is 1. Hydrogen everywhere is
Okay.
1. This is what I wrote
Okay.
there in the previous slide. Now, nitrogen is having 3 and 5, carbon is having 4, oxygen is having 2, hydrogen is having 1. The same thing I wrote there. Now,
Yeah. Yeah.
now see, now see one more. Ammonium cyanate, NH4, NH4,
Hmm.
CNO. Now see, here I'll be asking you a question. This
Okay.
is NH4. Fine, this is NH4. Here This NH4 is having a positive charge.
Okay.
Now see, can you tell me here what valency nitrogen is showing?
A 4, which
No.
is too much.
Yeah, see here. 4 na, you have said 4 na. You have
Yeah.
said 4 na. You have said 4. You have said
Yeah.
4. See, 4 na.
Yeah.
And one plus charge is there na.
Yeah.
So 4 minus 1, reduce 3. Plus charge, then you will reduce the valency.
Oh, okay. If it has plus, then you reduce valency. Okay.
If suppose,
Because
if
plus means excess, it's not stable.
plus means loss of electron na, here what valency of
Yeah.
nitrogen you have written here?
Yeah. It's
What?
2.
No, what valency of nitrogen you have written here?
4.
No, red one, encircled one, this red one.
2, 2, 2.
2.
2.
So what you need to do, you have to write one negative charge. Now it is having valency 3.
Okay.
If you have
So the
added
sign of
minus charge,
the
yeah, if you have added minus charge, means there will be increase in valency. Instead
okay.
of 2, it will be 3. But if you have written plus
Right.
charge, if you have written plus charge, then means that there will be decrease in valency. Instead of 4, it will be 3.
Um. mm, Okay.
Now, what should I do to make its valency proper?
You remove one
Yeah,
hydrogen.
just a minute.
Okay.
What should I do to balance it?
Um. You add a plus, make it a
Plus
positive
charge.
charge.
Now, very good, man, very good. Now the valency of oxygen is what? 2.
Two.
You know the
Yeah.
valency of oxygen is 2 now, but
Yeah.
here you
2
wrote 3.
oxygen
So
and
how we can compensate it? How we can make it proper? By putting a positive charge.
okay.
That's very,
But what
very
if you have
good,
two?
man. Yeah, it's a very, very good point, man. Even those who are there, they
Hmm.
are in AS level, they also do not know this all. AS or A plus level. They also do not know this all. And this all you won't be getting there in the books, but that's what true is. It is. That's what correct it is.
Okay.
Now